Hi, this is Dr. Robinson. I am attempting to make a quick EOC review. So, Algebra EOC, I am using the ALDs as a reference for this review. So, if you see me toggling back and forth, then know that that's what I'm doing. Okay, so the first topic of discussion is going to be solving real life problems involving function notation, domain, and range, and the comparison of functions. A function is written with f of x, and if the function is 2x plus 3, then that means that this function starts out with 3, maybe $3, and it increases, let's say $2 per hour. This will be a linear function. You could go to Desmos and type this in, and it would be typed in as y equals 2x plus 3. If you press the settings and the table button, it will pull the table of values, and then we can find different values for different points. What that tells us is that this graph is going to intersect at 3, and then the slope is going to be 2 over 1. So you're going to rise 2 and run 1. There's an XY table as well. X will be your domain values. Y will be your range values. Have a seat. No, baby. Negative 2, 1, and 3. I'm using the values from the table. And if we wrote this in, I don't see 3 on here, so I'm going to type in 3 and it gives me 9. If we needed to find function notation, domain, and range, then we would have the range will be all real numbers because this is going in both directions on the y values. Range is the y, all real numbers, and the domain values, since it goes in both directions, the domain and the range values are both all real numbers. So I put domain. You may also see them written with a capital R, or you may see negative infinity to positive infinity for the domain and also for the range. If it is a quadratic function, then your range values may stop if this is at 2. Let's say that this vertex is at 3, 2. That's H and K. We shift 3 and then we go up 2. The range of this quadratic will be from positive 2 to infinity. And the domain value, since it's going in both directions, will be from negative infinity to positive infinity. Alright, that is going to cover function notation, domain, and range. Oh, I wanted to show you one more thing about function notation. F at negative 2 for this function is equal to negative 1. F at 1 for this function is equal to 5. That's function notation. Moving on. Alright, on the next set is solving multi-step problems involving distance, midpoint, and slope, along with geometric properties plotted on the coordinate plane. For that problem, I want us to look at this order pair, 2, 3, and 6, 7. We're going to study slope, distance, and midpoint. I always tell students to make a table of values because it's easier to read the x and the y values. For all of these, we need the change in the y and the change in the x. Slope is going to be the change in y over the change in x. Distance is going to be the change in the x value squared plus the change in the y value squared. Midpoint is adding the x's and dividing by 2 adding the y's, and dividing by 2. All of these are available on the formula sheet. You will have that formula sheet in the DRC platform. So you'll click the icon for the formula sheet when you need this to refer to. Okay, over here, the change in the x values, you're going from 2 to 6. I want you to imagine on a number line that is an increase of 4. And here we're going from 3 to 7. That is also an increase of 4. So the slope of this problem is the change in y, which is positive 4, over the change in x, which is positive 4. That gives us a 1. The distance is the change in the x, which is 4 squared, plus the change in the y's, which is 4 squared. 4 squared is going to be 16 plus 16, and you would take the square root. Now, in Desmos, you can actually put this formula in. What we had typed is, I'm going to come down here, and I'm going to press the square root symbol. The change in the x was 4 squared, plus the change in the y was 4 squared. There's the distance between those 2 points, 5.66. Now, that means that if these points were on a coordinate plane, 2, 3, and let's say 6, 7 is all the way up here, that means that the distance from here to there is 5.66. The slope of the line, which is the rise over the run, is 4 over 4, which is 1. Now we're going to find the midpoint between these, which we add the x's. We got 6 and 2, that is 8. 8 divided by 2 is 4. And then we have the y's, 7 and 3, which is 10, divided by 2, and that's 5. So the midpoint will be located at 4, 5. You can verify that using Desmos and putting it in as an ordered pair. I'm going to show you how we do that. Alright, so the ordered pairs are 2, 3, and 6, 7. If I come over here to Desmos, I'm going to close this, and I'm going to type in 2, 3, and I'm going to type in 6, 7. I found the distance between these two, I found the slope between them, and I found the midpoint. The midpoint is at 4, 5. And you can see that it is in the center. If we took our cursor, we could move rise over run, rise over run. All our triangles will be 4 over 4, which is 1 over 1. Fall 1, run 1. Fall 1, run 1. Fall 1, run 1. Okay. We are moving right along. We now know how to solve complex problems. Oh, perimeter. Sometimes you might have to find the perimeter of these figures. So it might be like a triangle on the coordinate plane, and they ask you to find the perimeter. In that case, you still need to find the distance between each of these. So I would find the distance between this and this. And if I had a third point at negative 3, 5, I'd find the distance from here to there, from here to there. You'll have the distances around all of the sides, and then you add them together to find the perimeter. The perimeter is adding all the sides. You can guess if you don't want to do the work. You could probably use like your little scratch paper and measure the coordinate plane, and then use it to track how far it is around it. So I would probably measure, if this is like a coordinate square, then I would place this square and see, okay, what is the perimeter from here, and just mark it on my screen. I don't actually write on the screen, but it's a little easy way to figure out approximately what the perimeter of a geometric figure is. Alright, moving on. Solve real-life problems involving inequalities in two variables by graphing. Okay, inequalities. Inequalities, I think it's important that you know the words. Some of the words that you might see at most, at least. It's important that you know what those words mean. But if you don't know what those words mean, then you just need to be able to graph and interpret. If it is